Okay. Today's class, we need to discuss about schedules involving aborted transaction. We know that abort means while transaction is executed, if any problem is there inside the transaction is automatically stopped, which means that abort transaction. If any failure is occurred inside the transaction, if the, then the transaction is aborted. Okay. After that, the transaction is rolled back. That is the abort transaction aborted. Here, the scheduling involving a aborted transaction means so if you consider two transactions T1 and T2, here read of A equal to A minus 100, A equal to A minus 100. Write that value. After the completion of this T1, we have to start read of A equal to A plus A into 6 by 100, right of A. After this, read of B. We have to update that amount into the B. B plus B into 6 by 100, right of B. Then apply commit. After this commit transaction in transaction T2, the transaction T1 is aborted. Abort. So look at here, we have two transactions T1 and T2. In T1, in T2, in T1, suppose these two are two transactions. The T1, here the T1 decrement 100 rupees from account A, and then immediately before committing it, it reduce amount 100 rupees from the account A, and immediately the T2 started. The T2 reads the current value of account A and B, account A and B, and adds 6% interest here, 6% interest to each 6% interest to each account, A account and B account, then commit. But incidentally, if you see T1 after this, after adding 6% to these two accounts, if you see here, the T1 is aborted. The T1 is aborted. Okay, the transaction is not completely done. When A value is reduced from the 100 rupees reduced from the account A, after that it reads T2 reads A account and B account and adds 6% rupees to the account A and account B, then committed. Soon after, the T1 is aborted. The T1 is aborted, right? So here the T1 is aborted, so we get incorrect result of the T2. Incorrect result of the T2 because the T1, the T1, T1 was aborted in the middle of the process. In the middle of the process, before aborting, it is committed. After that, is committed before updating this A value. So the transaction T1 is aborted, right? T1 was aborted in the middle of the process, and the T2 has taken the T2 has taken incorrect value of A, incorrect value of A by T1, and add 6% and add 6%. We say that schedule such schedule is called unrecoverable schedule. Unrecoverable schedule or irrecoverable schedule, right? So you remember, after this transaction, if any transaction is in a position to be aborted, then that transactions are called what is that, irrecoverable or unrecoverable schedule. Because so before aborting, the a is read some miss what is that wrong value taken, and a process after that commit, the the T1 transaction is aborted. If it is commit, okay, everything is good, everything is good. If it is not commit, if it is aborted, then the T1, there may be chance to get a wrong value from the in the A, read the value from the T1, it is incorrect value. Then after that, after this, so this process is called irrecoverable schedule. Already we committed here, we cannot roll back. Okay, that is called whatever the read by the uh, A value, that is already committed. So the red value is we know that so what is that what is that wrong value. Even though wrong value, it is committed, we are not we cannot roll back that value. So that this is called as irrecoverable schedule. For suppose if you take 600 rupees a 600 rupees a, okay, so here the a value is after reducing 100 rupees, 500 is there, right of a. Now the value of a is 500. So here the 500, this is taken by a in transaction T2. So it reduces, it adds 6 percentage of a, and add to the a account 6 percentage of b, and add to the b, right? So here here read that value 6 percentage. Okay, this is okay. If you see here, a equal a minus 100, this is 600. After that 500. So this operation belongs to this one. But here, after committing this transaction, the T1 is aborted. T1 is aborted means not 500. Okay, not 500, not yet committed. So again the value of a is 600 only. That is the incorrect result, the incorrect input. So that this type of schedule is called as irrecoverable schedule. Whereas recoverable schedule is one which transaction read only the changes after they committed the transaction. Okay, once the transactions is made by the transaction T1, we have to commit, then only the the schedule is called as a recoverable schedule. If we are not unable to recover that one, that schedule of that type of schedule is called as a irrecoverable schedule, right? So again, one more important point topic is that we have, this is very very important. Without this question, there is no final exam. Serializability. Serializability. So this is very very important, right? It is a method. Basically, it is actually this is a method that ensures the consistency of the schedule. We need to say if this schedule is consistent schedule, so that we have to check the serializability of the schedule, right? A schedule is basically consistent. So when we can say if and only if it is serializable. When we can say uh, if the schedule is consistent data, then we can say that the schedule is in serializable, right? So for suppose a schedule is said to be serializable when if the interleaved transactions produces the result which is equivalent to the, right? So the result produced by the executing individual transactions separately, which means that serial means the interleaved transactions given one result. The serializable schedule gives one result. If these two are same, then we can say that the schedule is in serializable schedule. Okay, a schedule is serializable if and only if it produces some result as that of the serializable schedule. Right? Both are same. Right? Right? Okay. So if you take an example, serializable serial schedule, we have two transactions T1 and T2 complete. T1 completes, then we have to start read of y, w of y. Once you complete this one, then we have to start read of x, w of x, read of y, w of y. Okay, this is one transaction. T1 and T2 transactions are there. Okay, T1 complete, after that we'll start T2. This is a serial schedule. Whereas in the case of interleaved schedule, if you take T1 and T2, okay, R of x here, W of x. After that, we can write read of x, write of x. Next, after this, read of y, W of y. Okay, read of y, W of y. This is interleaved execution. This is interleaved. According to serializable schedule, this is serial. This is interleaved, which means that concurrent control interleaved. According to serializable schedule, these two schedules, if these two schedules produce same result, produce same result, then we can say that these two are serializable schedule. Serializable schedules, right? You remember the result of the serial schedule and the result of the interleaved execution or concurrent schedule, both are same, then we can say that these two are serializable schedules. We know that what is the table for how to represent serializable schedule in the transaction T1 T2, and in the same way concurrent fashion, how to write that concurrent fashion, we know that, right? This is concurrent fashion, this is serialized. So we have two different types of serializable schedules are there. They are two types of serializable schedules are there. Very, very important. This is very, very important. So two types, two types of serializable schedules, right? So the one is conflict serializable, and the second one is view serializable. Conflict serializable, view serializable. When we can call it as, so conflict serializable, when we can call it as view serializable, we have to see, right? So see here, the first one is conflict serializable. This is very, very important. Consider the schedule S1. The schedule S1, this is one schedule consisting of two successive instructions. So we have two instructions. So IA, instruction A, and instruction B, IB. Okay, these two are in the transactions respectively TA and TB. IA and IB belonging to the transactions TA and TB. These two are happening in that schedule. Yes, one. Then, if what is the problem if the while doing these TA and TB transactions, right? If IA and IB, you see here, this is very very important. If IA and IB refer, okay, different data items. Instruction and IB instruction refer two different data items, then it is very easy to swap these type of instructions. Easy to swap these type of instruction. Next, the result of the swapping these instructions does not have any impact on the remaining instructions in the schedule. We can see what is data item, how to represent this instruction A and instruction B in the transaction T1 and T2. On the other hand, if IA and IB refers to the same data in here, different data item, we can swap. On the same data item, same data item, then the following four cases are there. We have four cases are there. If remember, so we have two cases are there. One is, first one is, if IA instruction and IB instruction refer the say different what is that different data item, we don't have any problem, we can swap these two instructions. Whereas in the case of if IA and IB refers to same data item, same data item, then we have four types of cases are there. The four types of cases are very important, very important. Since because of this one, so we have four cases. Read and write operations are performed on this instruction A and instruction B. You remember we have what are the conflict problem? What are the non-conflict problem? When we get conflict, when we are not, when we are getting a non-conflict. See, for suppose if the transaction like this, W2 of A means here also data item A, here also data item A, and the read and write operation is performing on the same data item, then we can get a conflict, right? And one more thing is write of A and read of A. This is T1 transaction and T2 transaction. Okay, so this is W1 of A, R2 of A, write and read operation applying on the same data item. This is also one of the conflict. Write of A, W2 of A. If these two are write operations on the same data item, we can get a conflict serialized. Then what is the non-conflict serializable? R1 of A, which means that read of A, R2 of A, we don't have any problem. These two are read operations on the same data item. There is no conflict, right? R1 of E, R1 of B, W2 of A. You remember these two are different operations on different data items. Then we don't have any problem. Then we don't have any problem. This is about conflict serializable schedule, conflict conditions and non-conflict conditions. Conflict conditions and non-conflict conditions. So we have to take like this already instruction IA and IB we are representing. In first case, IA equal to read of X, IB instruction read of X. Next, IJ equal to read of X, IB equal to W of X. Next, IA equal to W of X, IB equal to R of X. The fourth condition is IA equal to W of X. Next, IB equal to W of X. So here, these two are IA and IB. These two are instructions, the data items. So here, read of X, read of X. This is one schedule. Read of X and write of X. Read operation on the same data item. Write operation on the same data item. Read on the same data item, and write on the same data item. These are the four cases. These are the four cases. Now we have to discuss one by one what is the case one and what is the case two, right? So here case one, case one. What is the case one? If you consider both IA and IB, these two are read instructions, right? These two are read instructions. We know that. In this case, the execution order of the instructions is not considered. This is also read. This is also read. If you start A, after that, if you start B, or if you start B, next after that, if you start A, both both are same. In this case, the execution order of the instruction is not considered. We are not considered because these two are same. Okay, since the data item X is is read read by the data item X read by the transactions TA, consider TA and TB. That is, either TA can read the instruction IA before TB reads IB, or vice versa. Either of the cases, okay. This is about if these two instructions are read on the same data item, there is no, we are not following any order of the execution. Either of one should be start. So if you start with A, TA, then after that TB, or if you start with TB, after that TA, both executions are same. This is first case. Whereas in the case of case 2, case 2, here if you observe here, IA and IB, here read operation, here write operation. Okay, we have instruction IA and IB. In IA, read operation is there. In the IB, write operation is there, respectively. If the execution order of the instruction, IA after that IB, which means that if the execution order of the instruction IA after that IB, then the transaction TA, here TA and TB, okay, the transaction TA, here TA cannot read the value after some transactions, the transaction TA, right, the transaction TA cannot read the value written by already written by transaction TB, right? TA cannot read TA transaction cannot read the value written by TB. Okay, TB in the instruction IB, right? On the other hand, if the execution order is like this, what is the execution order is like this? If IB starting first, IA starting next. After that, once you complete IB, after that IA, then the TA can read the TA for suppose TB and TA. The TA can read the value written by the transaction TB, written by the transaction. Here the TA can read value written by written by TB. This is transaction. This is second case. In this case, the execution order is more important. This is a execution order is more important. You remember, because read operation, write operation on the same data item. If starting with the TA and after the IA and after that IB, the TA, the transaction TA cannot read the value written by TB. First one. Next one, if your transaction follows IB tends to IA, the TA can read the value written by the IB. Okay, these two are conditions. Okay, so by seeing these two conditions, here the order is execution order is very very important. Execution order is very very important, more important here, right? And if you see here IA and IB, third case, case 3, case 3, right? What is case 3 here? This is the case 3, write of X, read of X. In write of X, in instruction A, TA transaction, in read of X, in the instruction IB, in the transaction TB. If you see here, this is the opposite to here. Okay. Previously, second case, read is in IA and write is in IB. Here, the write is in IA and read is IB. By seeing this, if you compare this one, this here also the execution order is very very important. What is the execution order? Here IA and IB, the operations are write and read operations. We are applying these two operations on the instruction IA and IB, right? If the execution order is IA tends to IB, then the instruction IB or the transaction TB can read the value written by TA. But if the order of the execution is like this, IB tends to IA, here the transaction TB TB cannot read the value written by TA. Cannot read the value written by TA. So that we have two conditions are there. So that here also the order of the execution is more important here. Right? So where in the case of case 4, if you observe here write of X on the same data item X, X. Right? Here IA and IB are these two are what type of operation? Write operations on the instruction IA and IB. Right? In this case, the order of the execution also does not matter. If the read operation is performed, if the read operation performed before the write operation, before the write operation, then the data item which was already stored in the database, already stored in the database read. Now, if the W of X operation is performed on the data item X from the database, then already stored in the data item X is overwritten by the new data item X. Already we have two instructions under T and TP already data item stored in the database. If you want to perform the case 4, W of X means already one value is there, some 6 X equal to 6 is there. I want to write that write that operation X item X value So already instead of that 6, we can, if you want to, based on your requirement, we can update that value. That is overwritten by new data item. If the R of X is performed, or suppose if the R of X is performed, the operation, then the data item X is read, right? R of X means data item X is read, but no, there is no earlier, what is that, stored value. If you perform the read operation, there is no earlier read operations. Already data is stored. From that value, we are reading that value. So here two instructions IA and IB, IA and IB are said to be conflict. When we are calling it calling it as conflict, two different operations, performed on the same data item. So here, if you observe, read, read, two different operations are performed on the same data item, which is called as X. This is one conflict. Okay. The second one is at least one write operation is involved in the schedule. At least one write operation is involved in the schedule. That is also one of the conflict. Here, if you observe here, if you observe here, for example, if you take if you take two transactions, T1 and T2, R of X, W of X, R of X, W of X, R of Y, W of Y, R of Y, W of Y. This is one transaction. Here, if you observe, the write of X operation here in T1 conflicts with the read of X operation in T2. The write of X operation is conflicts with read of X in T2. But the write of X operation T2 does not conflict with the, this is not conflict with the read of Y operation T1. Since these two instructions performed operations on the two different data, this is Y, this is X. Whereas in the case of here, these two are producing conflict serializable because the data items are same according to case 2. This is conflict serializable schedule. Conflict serializable schedules. If you observe, so one more topic is the second one is view serializable. View serializable. Okay. This view serializable also very important. We can cover this topic in the next class. What you have discussed today, so we have discussed what is a recoverable schedule, what is irrecoverable schedule. So which means that the irrecoverable schedule means if the schedule involving any abort transaction, we cannot recover, once you committed that one. Okay, the transaction one is debited some information. Okay, so before commit the transaction T1, the T2 is started. So we are doing some operations after, by taking a T1 transaction output. After that, the T1 is aborted. So after the committed information of the T2, we cannot roll back. This is called as a irrecoverable schedule. Whereas in the case of a recoverable schedule, which means that we have to maintain one which transaction read only the changes of the committed transactions. So means read and write operations are done, then commit, and read and write operations are commit in T1. Then we can say that this is called as a recoverable schedule. So the second topic is we have serializable schedules are there. When we can say that a serializable schedule, if the serializable schedule performing in two ways, one is concurrent fashion and the serializable fashion. The result of the serializable fashion and the result of the concurrent fashion, If these two are same, then we can say that the schedules are in serializable. So in serializable schedule, we have two types are there. One is conflict serializable and view serializable. So we have seen what is conflict serializable. We have four cases. Okay. So the first, actually, we have two cases are there. So the operations are so for example, two data items are there. Two data items are same, and same operation is done on this data item. Then no problem. The two operations are different. If it is read or write or read on the same data item, then we can get some conflict. That is called as a conflict serializable. And next, second one is view serializable. We can see the next class. What is view serializable? Okay, this is very very important. You have to remember. Once you complete this one, go to some other textbook and material. If you read, you can understand easily. Okay. So this is about today's class, sir. I'll stop the class. Okay. Okay. Thank you.
Thank you, sir.
Okay. Thank you all. Thank you all. Thank you. Thank you.